Good, fine. So this topic is what exactly? Construction and working of hydrocyclone, right? So we have started the topic that is classification, right? And we already talked about classifiers. If you remember, we have two categories of classifiers. One is gravitational, one is centrifugal, right? And already we have discussed about the gravitational classifiers, if you remember. Yes. Mechanical classifiers, sedimentation classifiers, all are basically gravitational classifiers. And if you remember, gravitational classifiers are still there in plants which are very old. Still they are using, right? But there is a major limitation of it. The major limitation of it was, it is expensive actually. The installation cost itself is very high. That is one of the major drawback of gravitational classifiers. But nowadays the industry, they are utilizing this kind of classifier, hydrocyclone. If you go to any nearby industry also, many mineral beneficiation plant, they are using this one mostly because it has lot of advantages. I'll talk about that later. So first of all, I'll take, so you have to understand this one is what kind of classifier? Centrifugal. That means centrifugal force will be acting on it. Centrifugal force will be acting on the mineral particles. But in gravitational classifier, there is no centrifugal force. Only because of gravitational force, only the particles are getting settled, right? And classification, if you remember, it is a size separation technique. We are just separating the size which is coarser, which is finer, right? This is classification only, no? Right? Anyway, so construction, let me draw it. This is important for example. Discharge. So you have inlet also. This is your underflow. And this one is your what exactly? This is actually FX, and this one is vertex. So this is about construction of your hydrocyclone. Right? So from this diagram, you can say hydrocyclone is a classifier having what kind of construction? Cylindrical and conical. In a simple way, right? Because this part, top part is cylindrical and this part is conical. Right? So you can see this is the feed end, and what will be the feed? Who can answer? What will be the feed? Slurry. Where it is slurry? It is a mixture of water and fine particles. Because after grinding we get slurry, right? So this will go like this. So how the mineral particles are moving in a spiral manner, right? What exactly we are doing? we are allowing our slurry to go in a tangent manner. Tangentially we are feeding the particles or feeding the slurry. So why we are feeding tangentially? So that they can acquire a spiral path like this. Fine. So this is coming like this and it will go like this in a spiral path. Right? So particles or slurry are in spiral motion here. Right? So that's why we are feeding it in a tangential manner. But the interesting point is, so it will also have a inner circle kind of this, inner spiral. I discussed about this. So it will go like this and come out. So this is your inner spiral and this one outer. So now I am talking about the working principle, right? So you can simply write that the slurry is fed into the cyclone in a tangential way, so that the slurry or the particles will acquire a spiral motion, right? And you understood what exactly. Of course, the particles which are coarser, heavier, basically coarser, that will go down, of course. So you will get underflow. You may get a question in exam, right? What is underflow? We can write what is an underflow. Underflow means heavy particles, coarser particles. Because we are doing size separation, coarse or fine. So coarser particles will always report to underflow, right? And what happens to the fine particles? Actually, they go out from the top, that is overflow. So overflow are the small particles or lighter particles. Okay. So can you think of it? Why this is happening? Why some particles is going up and why some particles is going down? Because of weight, of course. That is fine. But here also we are applying. So on the particles, what kind of force will be acting? Centrifugal force, of course, right? Centrifugal force is always outward, right? And if I talk about the drag force, if you remember now, when you allow some minerals to pass through a fluid medium, what kind of forces are acting? One is gravitational force, which is downward, and upward force is the buoyancy, and a drag force will be also there. A drag force is what? Upward, right? Drag force is the force due to friction between the mineral and the fluid, right? There was a question I think in the mid-semester, I don't remember. Okay, but exactly in this condition, buoyant force have no role to play mostly. Just remember that. Why? Because we are intentionally providing the mineral in a tangential way so that it can attain a spiral path and go down. We want the particles to go down. So that means buoyancy is negative. The buoyancy force is negative. Two forces will be acting now. One is the gravitational force, which is downward, and drag force. Because water is there, no? Water particles and mineral particles, there will be a friction, which one it should not move at a faster rate, right? So I will talk about the principle, how this is exactly happening, why some particles are moving up. The point is what exactly? See, this part is what exactly? This atmosphere obviously. Below this it is atmosphere, normal atmosphere, right? Here also what is there? Atmosphere. This is also atmosphere, right? But inside this what is there? Inside this mostly slurry is there, but liquid and solid, right? Inside this liquid and solid is there. And this is open to atmosphere and this is also open to atmosphere. So what will happen? Air also want to go inside it, of course, because this is open, right? And the point is, see, this is very interesting. This portion is wider, this portion is narrower, right? Wider portion is radius is more, this radius is less. So centrifugal force we know is equal to fine. So this is nothing but your radius. And pressure is equal to force upon area. Okay, right? So that is more is the force, more is the pressure, or in other way I can say if radius is less, force will be more, pressure will be more. Is it fine?
Yes.
So that means the pressure here is different from the pressure here. This is wider, more diameter, more radius. So pressure will be less. Here the diameter is less, pressure will be more. So there is a differential pressure here actually, right? And it is open to atmosphere. So That means in other way I can say pressure inside is more, pressure outside is less. And so what will happen exactly? The air try to move so that it will bring in equilibrium condition. So air wanted to move inside it to bring the everything in equilibrium condition, to maintain an equal pressure kind of. So that's why what is happening. So air, when the underflow is coming out, air is also going inside quickly. So the particles which are very fine particles, they are carried away by this air, actually, moving air. Fine. So moving air will carry away the fine particles and it will come out as overflow. You understood the concept?
Yes, sir.
Intentionally we want the particles to go down so that it attends a spiral path and it is moving down. But since air is also moving inside it, this air is carrying the particles, fine particles and taking it out. So you will get what? Overflow, fine particles, slurry with fine particles, here slurry with coarse particles. So this is the concept actually. But the point is, this classifier is very simple, just see, nothing is there.
Yes, sir.
This is just a cylinder and cone, nothing is there. So, if I talk about the advantage of this classifier, you can simply write, this is a very simple classifier. Very simple classifier. And installation cost is minimum. If you install a gravitational classifier, it will be expensive. But if you install a hydrocyclone, it is very cheap. Because nothing is there, just a drum kind of. So it is cheaper, installation cost is very low, maintenance cost is also very low. Right? And people call this classifier as the heart of mineral processing. Just imagine how important this classifier is. Right? So this is actually called heart of mineral processing. So can you tell me why we call a classifier as the heart of mineral processing? Can you justify it? That means indirectly I am asking what is the main need of classification. Can you tell me? That means we cannot skip classification. We have to do classification for mineral processing to get a concentrate at the end. So why? You know the answer, I know already. But here we are not doing any concentration. Classification means we are only doing size separation, coarse and fine. We are not doing any concentration. Concentration comes later. No? Next stage is concentration. So that's why I have given flow sheet, to draw a flow sheet. I am sure you people have made some mistake. I am sure. I am not sure. Okay, can you tell me?
Further step.
Yeah, further step. Yeah, he is partially right, but the point is the downstream process. Yeah, the entire downstream process depends upon classification. Downstream process is concentration, no? So if you want to do concentration, you basically want to keep the particle size uniform, same size kind of. Suppose 60 micrometer, 65 micrometer is uniform nearly, right? But if I choose a mineral having 100 microns and 50 microns, and I want to do concentration, the concentration efficiency will be very low. But if you choose minerals having 60 microns, 65 microns, 60 microns, 62 microns, that is fine. So your downstream process efficiency actually depend upon the uniform size of the particles. And uniform size of particles is either you choose this one, or you can choose this one. Because these are uniform size. These are also group of uniform size. You understand my point? Suppose for example this is 100 micron, let it be. Or suppose this is 20 micron. If I choose these particles and go for concentration, it is better. I am not considering mixture of 20 micron and 100 micron. I have to consider one single kind of micron, right? Or near size. Do you understand my point? But I told you this one. Yeah. In the earlier class also I told you this one. Why we need to choose uniform size particles for concentration. You remember? Anybody remember? You might get a question like this. Because most of the concentration process are gravity concentration, if you see, right? And gravity concentration depends upon the density or specific gravity. So that's why we want to keep the size same. If you keep the size same, and density will be different, somebody will attain more terminal velocity, somebody will attain less terminal velocity. You can separate the gangue and valuable minerals. Basically, valuable minerals are more denser. They are more heavy, valuable minerals. But the gangue minerals, they are lighter actually, always. Right? Silica is the major gangue in all the minerals. If you check most of the minerals, it may be aluminium ore, maybe tin ore, maybe iron ore, any kind of ore you choose, silica will be there. And silica is very lighter always. it's around 2.3 to 2.6 density, right? But if you choose iron ore, it is more heavier. If you choose gold, gold will be more heavier, right? Gold is very heavy, right? You understand my point? So that is the reason why this is called heart of mineral processing, because by doing classification using hydrocyclone, you will get a uniform size particles, and you can go for concentration process. It will be easy. It is fine. So this is done. Diagram. Okay. So diagram force on the particle motion. So I can draw it like this. So suppose I am. So it is in the spiral motion. So this is a particle, for example, and it is moving like this. This is the same particle. Spiral motion particle, right? So you tell me, this is direction of force, and this is the direction of force. I told you which kind of force is acting here. Centrifugal force and drag force. Buoyancy is not acting right now. Acting but negligible. Can you tell me in which direction drag force will be there? So this is moving like this, for example. See, just imagine this is moving like this. So one force will be inside, one force will be outside, right? Towards the wall and towards the center. So this is towards the center, this is towards the wall, right? So this will be very good, right? And this will be
Centifugal.
Is fine or any confusion? So if I am imagining my particles moving like this, so inside towards me it is drag and outside it is centrifugal. Centrifugal force is always outside, no? Towards the wall, and drag force will be inside towards the center. So you can imagine, that means most of the force particles will be towards where? Towards the wall actually. Of course they are heavier, no? They want to go because force is called mv square by r. Mass, it depends on mass also. Right? More centrifugal force means more mass is there, means more centrifugal force will be acting. So coarser particles will move towards the wall and finer particles will move towards the center. Right? So this is another concept. And center there is what? A inside spiral is there because of air, flowing air. So that will carry away all the fine particles and it will come out. And heavy particles, they will move outwards and they will go downwards. Fine? Up to this? Very good. Advantage is already told you. You can write. Fine. Now the gravity concentration we talk about, and this you will get a question from this definitely. So concentration. Okay, fine. So maybe I can draw like this as well. Okay, I'll draw a generalized force sheet better. So these are the fine. Next will be what?
Classification.
Okay, I can give here screening, and here classifier. Next step will be your concentration. Concentration or concentrator. Finally, you will be having
concentrate and telling.
very good. And this will go for what exactly? Metal extraction. Fine. And this will go for?
Secondary extraction.
You can dump it, or but nowadays you are not dumping actually.
Secondary extraction.
You can go for secondary extraction. No? Dumping or secondary extraction for the Then finally you get metal, marketable metal. Again, metal for market. Okay, dewatering, yeah, actually these are major things I'm talking about. You can write dewatering also. Obviously after concentration, if you want you can write dewatering. Basically what exactly we do, instead of writing dewatering here, you can write dewatering here. Here, after concentration. Because we don't want to utilize this one, we want to utilize this one. So you can write dewatering here. But okay fine. If you write dewatering again, then you have to write one more point. That is agglomeration. Okay. After dewatering means removal of the water. You have only solid minerals. Then these solid minerals are very fine. No? If you remember, I told you that you cannot feed fine minerals into furnace for metal extraction. You want lumps, right? For example, blast or to operate a blast furnace where you extract iron. You cannot charge fine particles like 100 microns, 30 microns. You cannot feed. You have to feed lumps of above 10 mm at least, above 10 mm size. That means again fine become lump. That is called agglomeration process. So basically, technically called pelletization and sintering. Sintering and pelletization, both are agglomeration process. Dewatering can okay fine. Then you can write also agglomeration if you want. Agglomeration, then you can go for metal extraction. Wait a second. And if you remember, if I want to make it closed circuit, so what I have to do? Can you tell me how I have to put arrow marks? I want to make it closed circuit. So what I can do? Right? Classification. Closed circuit. You know closed circuit.
Yes.
The courser will come back. Final will go to the next stage. Courser will go back again. Final will go to the next. Right? This is the closed circuit. I think there was a question in mid semester also. What is open circuit and closed circuit? And maybe you will get same question in the end semester. Right? Suppose the question will be like this: draw the flow sheet from run of mines to the metal market, a metal which you send to the market. Draw the flow sheet and show the measure components, or measure unit process and unit operations. You can show this one, right? And if the question, additional question will be make it closed circuit. So the arrow marks are important actually.
Yes.
And one important point you have to remember: whenever you are showing any unit process or unit operations, it should be in the square bracket, rectangular kind of brackets. But not bracket with box. This kind of box you need to use. These are one for unit operations. This is also unit operation. This is unit operation. But metal extraction is unit process, right? Because chemical process. These are physical. Right? It's fine. Absolutely. Okay, we'll talk about so you understood the position of concentration in the circuit, right? So after classification, we'll do concentration, right? So concentration means what exactly? In a simple way, who can answer? What exactly? Concentration means?
Valuable mineral separated.
Yeah, concentration simply means separation process. Because classification function is to do separation on the basis of size, right? So you get a uniform size now, and you want to do concentration. So that uniform size is a mixture of what? Gangue plus valuable mineral. You want to separate the gangue and valuable mineral. So that is concentration. Concentration is nothing but a separation process, right? We want to separate the gangue out of valuable minerals, right? Very simple. So one of the important concentration method is your gravity concentration. So itself it is saying gravity concentration means the gravitational force is the important factor here, right? And gravitational force will depend upon exactly what? It depends upon size, it also depends upon what? Density of specific gravity. These are the two important factors, right? Size is important and density is important.
The shape also.
Shape is also, already I told you that. But here we consider there is no role of shape here, right? And from classification, we have already kept one thing constant, that is size, right? So size is fixed, shape is, suppose imagine it is fixed, kind of.
Yes.
So what is the main role to play here? The density, right? Or specific gravity is more important now. And always it is there, the density of gangue and density of valuable minerals are always different, which we want to separate.
Yes.
So it can be easily done by gravity concentration. Right? Okay, so let me tell you a good example in the real situation. Okay, can you stop the recording and start a new video?